While working on some example code for an upcoming Lambda Island episode, I ran into an issue, a problem with dependencies. It's the kind of thing that easily happens, and I was quickly able to solve it and move on with what I was doing. But then I thought, people run into this kind of thing all the time, and unless you have some experience, it's not obvious at all what the problem is, or how you go about solving it. So I decided to take a step back and document exactly what I did to figure this out and solve it. The project is called booklog, and you can find the code on Github. Grab the branch dependency error to recreate the problem. In this case, the last thing I had done was adding Buddy to the project, a library that handles authentication and authorization. Buddy is split into several projects. Here I'm using Buddy Auth and Buddy Hashers. So far so good. I've started a new REPL to make sure the newly added dependencies are downloaded and available on the class path. Now I try to require the buddy.auth.backends namespace. And boom, there's the error. In this case, you only get a one-line error message. In other circumstances, you are more likely to see long stack traces. There's a lot of information in this one line, probably enough to point you in the right direction. But if you do want to see the full stack trace, then you can check the *e variable, which contains the last error that was raised. In my case, I was actually working from Emacs and Cider. So I'm in this namespace, adding Buddy Auth backends to the list of required namespaces, and then when reloading the file, in Cider that's Ctrl-C, Ctrl-K, I'm greeted with this Cider error buffer. When something like this happens, first take a step back and think about what you were doing. What changed? If you can go back to a previous version of your code that still works, then you can compare the two, and this should give you some pretty good hints. In my case, I was trying to require Buddy. If the require isn't there, everything still works, but once I add it, things blow up. This isn't always so obvious. Say you revisit a project after letting it rest for 6 months. You start by bumping the dependencies in your project.clj to their latest version, and then try to start a REPL. Boom. In this case, it's not so obvious that requiring Buddy is causing problems. But on the other hand, you do have a great data point. It has to be something with the dependencies. Half of the effort of bug fixing is just carefully reading error messages. So let's have a better look at these stack traces. The two things to look for are what went wrong and where in the code did it happen. Errors in Java, and hence also in Clojure, are called exceptions. They have types like Clojure lang compiler exception or Java lang no class def found error. Sometimes one exception will trigger another one, which might trigger another one, and so on. You can see this in the stack trace where it says caused by. In this case, a Clojure compiler exception was caused by a Java no class def found error, which in turn was caused by a Java class not found exception. In other words, the Clojure compiler had a problem because it failed to find the definition of a class, because trying to load the class failed. So the root cause here is that it didn't find a class that was expected to be there, namely the format feature class in the com_fasterxml Jackson core package. That's a pretty good indication that something is wrong with the dependencies. Now the next question is, where did it happen? In a sense, it happened in many places. Every line in that stack trace is a call in the code that failed to complete. Notice that most of them are functions internal to Clojure. It's not that likely that the bug is actually in Clojure, so you want to scan the stack trace to find instances of library or application code. The interesting bits are usually the last place in library code that was called, and the last place in our own application code that was called. Stacks grow upwards, the last thing added is at the top, and it's no different with stack traces. So the first thing to look for is the topmost line that points at library code. The first third-party library in there is Cheshire, a library for encoding JSON. It seems it was trying to invoke require. Further down you find Buddy, which was also doing a require, so it seems Buddy was trying to load Cheshire. So all of this here is just Clojure requiring a single namespace. No wonder these stack traces are so bloated. Hopefully tooling will get better at filtering these out, but in the meanwhile we have to make the best of it. If you cut out all the noise, like I did here, then you can see that the problem ultimately originated in the first line of the booklog application namespace, which is where the namespace declaration is that loads buddy, which then loads some internal namespaces, one of which depends on Cheshire. And apparently, Cheshire needed the format feature clause, but couldn't find it. It's possible that Cheshire doesn't properly declare its dependencies, and that's why the clause isn't there, but it's unlikely. More likely is that the dependencies are in a bad state because of how library dependencies interact. The best place to start looking for dependency problems is line deps tree. This shows you a detailed overview of all dependencies that are being loaded. Each library might pull in other libraries, which is visualized by this tree structure. Note that a single library could be a dependency of many other libraries, but Leiningen will only show it once in the tree. If you scroll back to the top, you find a list of warnings about possibly confusing dependencies. Multiple libraries might have the same dependency, but they don't necessarily depend on the same version. This means Leiningen needs to make a choice. Does it pick the version required by library A or the one asked for by library B? There's no perfect solution. Leiningen needs to guess. That's why it's warning you that maybe its choices aren't ideal. The relevant section for us is this part. Both Transit and Buddy indirectly depend on COM_FASTER_XML Jackson core. Transit wants version 232, whereas Buddy, through Cheshire, asks for 286. Now you can see how this plays out in the actual tree of dependencies. Underneath Transit, you see Jackson core being pulled in at version 232. Underneath Buddy, Jackson core isn't listed at all, even though it's a dependency of Cheshire. So Transit is getting priority here and overriding the version requested by Cheshire. There are two ways to solve this. The easiest is to explicitly add the right version as an application dependency. Direct dependencies like these get preference, so this overrides both the Cheshire and the Transit dependency. You can verify this with linedeps tree. The warnings for Jackson core are now gone, although there are still others that you could look into. Now, instead of being shown as a dependency of Transit, Jackson core is listed as a top-level dependency with the version we asked for, 286. You can think of this as the brute force approach. Just hardcode a version to make the problem go away, but it has its drawbacks. Before, the version of Jackson core was declared twice, once by Cheshire and once by Transit. Now it's declared 3 times. If you end up updating Transit or Buddy, or you add other libraries to your project, the chances of conflicts will only get bigger. The better approach is to give Leiningen a gentle push in the right direction. Leiningen already showed you how to do that as part of the warnings. You can add an exclusions vector to a dependency declaration. This tells Leiningen it should not bother with this transitive dependency. It's as if Buddy or Cheshire never depended on this library at all. This way, the dependency through Transit will be favored, and it will use version 232 instead of 286. That's not what you want though. Version 232 is exactly the one that caused the problem. In this case, Leiningen's suggestion isn't great, but with what you know now, you can also decide to do it the other way around. Tell Leiningen not to bother with the Transit dependency, but to favor the one used by Buddy and Cheshire. If you do this, then 286 gets used. It's the newer version of the two, but it still has the same major version number. This makes it highly likely that it's backwards compatible with version 232. Many library authors promise to only introduce breaking changes in major releases. This is part of the versioning conventions known as semantic versioning. You can verify once more with linedeps tree that all looks good now, and indeed, if you run the project, this time the error is gone. You could leave it at that and move on. After all, your problem is solved, and you have work to do. It's likely though that someone else will run into this problem as well, given that Transit and Cheshire are both popular libraries. It might even be you a few months from now. The root cause here is that Transit hasn't kept its dependencies up to date, so you can open an issue or pull request to have that fixed. When engaging in open source like this, there are 3 things to keep in mind. Be friendly, be helpful, and be patient. More often than not, the person on the other end is volunteering their free time because they enjoy doing open source. Don't ruin that feeling. Be helpful by providing as much relevant information as possible. In this case, I can mention the old and new version, and the fact that it clashes with Clojure, which shows that this is a real-world issue. You could go one step further and run the project's test against the new version to see if anything breaks, after which you submit a pull request. This is assuming the project accepts pull requests, which is not the case for Cognite projects like Transit. Finally, be patient. In this case, Alex Miller was very quick to update the version and do a new release, but sometimes this takes time. Resist the urge to ping the maintainer or bum the thread. It's unlikely they didn't see it. The fact that the issue is documented is already helpful for others running into it.